Hi students, now I will talk about section 1.9 unit vectors. Let us look at the vectors in the previous section, the vector v and the vector u. If we need to take a common quantity between the two vectors, which was the x direction and the y direction. If we look now to the vector v, the length or the components of vector v is 3 units in x direction and 4 units in y direction. If you remember, we wrote it like this: 3 in x plus 4 in y. Also the vector u, we write it minus 2 in x and plus 2 in y direction. We will not use this notation to write these vectors or any other vectors. We will use another notation, which is the notation for a unit vector in Cartesian coordinates, which is in x direction we will put I hat. We will use the hat to denote to a unit vector. The unit vector is a vector with length just 1. Okay? And these vectors, even in x direction or in y direction, if we add them together, they will give us any vector we need as a superposition of these vectors. For example, vector v again is 3 units or 3 unit vectors in x direction, 3 I hat, 3 in x direction, plus 4 in j hat. For in this notation, the x direction, we will take I hat to denote for the x direction unit vector. For the y direction, we will use j hat. We will use this hat. For a vector v, we will use an arrow to denote for a vector. This hat is a vector, but it is a special vector which has a length just 1, and it direct to x direction with no angle about the x direction. It is with x direction, and the angle with x direction is 0. This j hat, the angle of j hat with y direction is 0. Also, we have in our life 3 dimensions: x, y, and z or z. So we will use also in z direction, we will use k hat. So we have 3 unit vectors, I, j, and k. It will be easy to use them. We will see that in the examples. Okay. Now, what about the vector u? Again, u is minus 2 in x direction, minus 2 I hat plus 2 j hat. There is no component in k hat. We can put it 0 k hat. We don't have any third dimension here. Look at I hat. I hat is always direct to the positive x-axis. This is I hat. But in the vector u, it goes in the negative direction, in x direction. So we will use the same I hat, but with negative argument. Minus 1, minus 1, it is minus 2 in this direction. This direction is 2 with minus sign in I hat direction or in x direction, and plus 2 j hat. What about s, which is the summation between u and v? It is 1 unit in I hat in x direction, 1 I hat plus 6 j hat. It's easy. Let us look at this example. What about the vector A? A, again, it is ax I hat plus ay j hat. Ay, it is the component of the vector A in y direction. But where is its direction? It is in the direction of j hat, or in y direction. As we see from the graph here, ax is 11.3 in I hat direction, and ay is 4.1 j hat. The same for B and the same for R. You can add the x component for A and B to find R in I hat direction, and the y component for A and B to find the y component for R in J direction. And also you can count these lengths with the right scale. What about this example again? We have 1, 2, 3, 4, 5 vectors R, A, B, C, D. Again, we need to write them in I and J hat notation. It is easy. Now, what is for the vector C? What is the x component for the vector C? It is, be careful that each unit is 1 unit in this scale. So the length of C is 1, 2, 3, 4. It is, but in negative sign. It is -4. What about the y direction? For the vector C, it is 2. 1, 2. The vector, it is -4 I hat plus 2 j hat. The direction, I need you to find the direction theta, which is tan inverse to y component over x component, 2 over -4 in degrees, or in degrees, okay? What about the length? The length, using the Pythagorean theorem, is the x component squared -4 plus 2. But I need to square them. Be careful. If you put just 2 as a power, 2 squared is okay. But if you put -4 squared in this way, sometimes we will, maybe me also, make a mistake and make it, because 4 squared is equal to 16, and you will keep the minus sign, it will be -16. That is wrong. We need to put -4 all of it to the power 2. We need to square all the value, okay? This is, you can do this for all the vectors, and you can fill this table again. Let us now look at the vectors in 3 dimensions. Now we have the vector we have the Cartesian coordinates x, y, and z. If we have a vector A, which is ax, ay, and az, but ax will be in I direction, I hat, j hat, k hat. Ax in I hat, j hat, k hat. This is the vector. And the length, using the general form of the Pythagorean theorem, or the Pythagorean theorem in 3 dimensions, which is ax squared, ay squared, az squared, all under the root. For this example, we have the vector P is written as 3, 0, 5. This is equal to 3 I hat plus 0 j hat plus 5 k hat. These are the components. The vector q, it is negative 5, negative 3, and 7, which is equal to negative 5 I hat minus 3 j hat plus 7 k hat. If we need to draw this vector from the origin, which is 0, 0, 0, this is the vector. This vector is the, look at the y component, it is 0. The vector p, it lies in xz plane. Okay, it will not be that difficult. Okay, in general we will not use these vectors in our study. We need just to be careful to deal with the vectors in 2 dimensions. Thank you.